Good afternoon, everyone. My name is Aish Manta, and I am the technology lead for construction and fabrication here at Fluor. I hope you are having a fabulous day. And today we are going to be having our information session number 3 of the 2019 New Veg Floor Design Challenge. And the topic that we're going to cover today is the civil design specific to the excavation and foundation design. I have with me from Fluor Ron May, who is the subject matter expert in civil design here at Fluor, and David Vogel, who is our pipeline SDS, is also on the call. We will start with the first. Ron is going to go over the civil section of it, and also start with the safety topic. And then post the session, we're going to open up the forum for all the students and professors alike for them to ask any questions. So with that, I would request all of you to mute your mic and also know that this session is being recorded. A recording will be made available to the students on the conference website once we have it, once WebEx uploads it on the website. So with that, I will, Ron, can you please share your screen?
Sure.
And over to you, Ron.
Okay, hold on. Give me just a moment. Okay. So can you see my screen right now that is showing the civil design section of the design challenge?
Yes, Ron, we can see your screen.
Okay, so you want me to open with the safety topic?
That would be great, Ron. Thank you.
Sure. So today, I don't know if you've been out and about in the rain that we've had today. I wasn't really expecting it to rain today, and so there was a couple times I was out and it was raining and I didn't have my umbrella with me. So I know sometimes when you get caught in that situation and you're trying to get to your car, you might decide that you need to run to get there because you don't want to get wet, and so that's really not a good idea because you're putting yourself at risk when you're running through the rain. Of course, things are more slippery when it's wet like that, and you can get injured severely, in that situation. In fact, here at our Fluor Houston office, we've had some cases where people have slipped and fallen due to wet surfaces around our building, and so we try to be very careful about that. And so in those situations, I would say make sure you have an umbrella with you in your backpack or whatever. You never know when it's going to rain around here. But also, if you find yourself in a situation where you need to get to your car or something, or you need to get to class, I would say just wait a few minutes, see if, it lightens up before you try to get out in the rain, because it's not worth risking your safety to be running through the rain like that. And another thing I'd say is allow yourself enough time, for contingencies, so that if you get into a situation and get delayed because of the rain, then you'll have enough time to get to class safely. Okay, so I'm going to be talking about the civil design portion of this design challenge today. I know that David had gone over in the last 2 sections. We had kind of an introduction session to talk about the challenge in general, and then he talked about hydraulics and the pump selection in our last session. Today we're going to be talking about actually preparing the site for the pump station and for the design of a foundation for the pump. This is one of the primary cost elements in your design challenge to calculate the amount of excavation and fill requirements and also concrete foundation requirements that will be required for your pump station, and the equipment that will be required to perform that construction. And all of that, has associated costs based upon how many cubic yards of excavation or concrete and, the duration of the construction. So we're going to go over all that today, and, we'll have a chance for you to ask some questions toward the end of our session today. What I have up on the screen right now is from the design challenge document that had been sent out, and this is revision 1 of that document. If you were at our session the other day, yesterday I believe it was, we talked about the changes that were made in the Rev 1 version, which are shown in red. Okay, so you'll see that today certain sections have been revised from the original issue, and now we are looking at Rev 1. So if you happen to have the document available, you can certainly follow along, and hopefully some of you have had a chance to read this beforehand, and we'll be able to address any questions that you have. So,
Ron,
yeah.
May I interrupt? Thank you. Great point, Ron. I just wanted to let the students know that this revision is actually up on the conference website. So in order for you to access the latest version, you have to go. Students have to go through the same process of logging in with their Kubernetes ID and password, and they should be able to download the latest revision of this file. Thank you, Ron. Over to you.
Sure. Okay, so in the design challenge, after you determine where you want to put your pump station along the route of this pipeline, then you'll need to look at what do you have to do to build that site. And so in the design challenge, you'll see here that it says that your team will determine the excavation required to build a 500-foot by 500-foot level plot of space for the pump station and all permanent facilities and access to the facilities by vehicles and personnel. So what you're going to have to develop is a 500-foot square level plot, and you'll notice if you look at the profile along this pipeline that there's not that many places that are already level for you to put a pump station. And so most of the route has slopes on the profile, and so that's going to require you to do some cut into that slope, and then of course that would be graded out into a level site. So you'll also know that there were different soil profiles provided along the route, and let me just point that out first of all. So these were the stations that we had along the profile, and you'll see that there's different soil types that we'll be dealing with, and just keep that in mind. That's in Table 3 in your handout. Okay. So when we're looking at the site, as David had talked about the other day, we're concerned about providing a stable slope. Okay, so you remember this these pictures up here. I believe we had one. Where is it, David? Here we go. Oh, right here. Okay, so this is an example where they had done some site work, and the slope was too steep, and then they may have had some rain and some other circumstances that created an instability in the soil, and they had a soil failure, and it all collapsed, as you can see here. And you may have seen this sometimes, in fact, right close around U of H campus over there. I know in the bayou they had some slope failures at one time when we had a lot of heavy rains. So it's really important that you understand the type of soils that you're working with and be able to design that appropriately to avoid these types of soil failures. Okay, so when we look at this, as you can see here, most of your profile, will be something like this, shown in this black line here. So it's different slopes along the profile, and to create a site large enough for this pump station, it may require some area of cut and fill, or a combination of the two, with the idea being that this level portion, let me blow this up a little bit, this level portion, like in here, would be like a 500-foot dimension. Now, for this challenge, for the first stage of this challenge, we've decided that we want you to look at it only utilizing cut, and that this cut material would have to be disposed of. And so what you're going to do in this case is find an area where you can put a 500-foot level area here, like right in this dimension, and then cut out the existing slope there, and then this would go 500 feet, into the page, basically, uniform depth, and you would calculate that volume, and that would be the volume that you would use for pricing out the equipment that would be required for the excavation, and then the dump trucks that would be required to dispose of this cut material. You'll also notice on here that there's a certain slope requirement that we would need to cut this to, that would be required to ensure that we have stability on this slope, and that we don't get a failure that would put our pump station at risk. So if you go up to this table 2, it will give you, based upon the different soil types, different parameters for the soil, and one of those is the maximum allowable slope, and they have a ratio of the horizontal to vertical dimensions, for the slope, and this will help you determine what this volume of cut material will need to be. Now you also notice that there's a certain excavation cost associated with different types of soil materials. If you're dealing with rock, it's a lot harder to excavate, as you can imagine. In some cases, they even have to, blast the rock to break it up and be able to excavate it. We're not going to try to include all of the different equipment that might be required to excavate rock. What we're simply going to do is put a factor on that, and that would include then more cost to account for the fact that it's more difficult to excavate rock. So the basic piece of equipment that we're assuming for the excavation is a track hoe. Now, obviously, there might be other types of equipment that's used, but to make this a more simplified exercise, we're incorporating all of the cost of any equipment and labor associated with that into the cost of a track hoe. Okay, so That's not to imply that that would be the only piece of equipment that would normally be required, but we're just trying to make it a little more straightforward for you. So in the case of the rock, when you get to your spreadsheet for the getting to the cost, you'll see that there's two different pieces of equipment for track hose, one for soil and one for rock. And you'll see that the rock has a $15,000 cost per day, and you know, you'll have to determine, well, how many track hose will I need and for what duration, so we can calculate this cost per day, right? And then the track hoe for soil is just $5,000 per day. So that's where you see on this excavation cost, this rock is at a cost factor of 3, and then the soil, whether that be firm clay sand or this medium dense sand, would have a cost factor of 1.0. Okay, so that's what this is relevant for. Okay, so you'll be calculating this cut volume, and then if we go down to the constructability part of this challenge, let me get to it. I passed it up. Hold on, give me a second. Okay, you'll see right here the equipment requirements for excavation. Really, is excavation and the foundation. And so the requirement for a track hoe is that it can handle 10 cubic yards per hour of excavation. So once you calculate your total excavation quantity, then that will determine, you know, how many hours of a track hoe that you'll need. Now, you don't necessarily have to use just one track hoe. You could use multiple track hoes if you want to, but you know, there'll be a cost associated with that. So you just need to decide what is the right selection of equipment based upon the time and the cubic yards of excavation required. And then, of course, the dump trucks, you can see here, all of the cut material we're going to assume has to be hauled off the site and will not be utilized for the construction of the site. And so each dump truck has a capacity of 12 cubic yards, and it has a 4-hour round trip. So that's how you'll calculate how many dump trucks you'll need and be able to come up with a schedule for doing this work. You know, you got to really look at what can I do in one day with the equipment I have. We want to make sure that we're staying productive with our crews and our equipment and utilizing that in the right proportions to be cost effective. Okay, so if we go back to our diagram for cut and fill, so like I said, in the initial challenge, we're just going to consider the case for doing cut and creating a 500-foot area here. Now, for the zero-based execution solution, which would be the secondary effort that we do, then we're going to allow this to be a cut and fill operation. And the concept for that is that what we would do is use a cut material and use that for fill material down here so that we don't have to haul off any material, and that's called a balanced cut and fill. And that helps keep your costs down because you're avoiding transportation of materials, and you're balancing out your need for both cut and fill. So in that case, you got to figure out, how do I best locate my site to be able to balance my cut quantity with my fill quantity, so hopefully I won't have to dispose of any excess material. And so that's the idea behind the cut and fill. Now, what I would say is in calculating your cost of equipment, you'll base it upon the cubic yards of cut. On where you have cut and fill, then you'll have to also include the track hoe for the cubic yards of fill. Okay, so it's two separate operations. Even though we're using the same material, you're handling it twice, once for the cut and one to place it and compact it for the fill. So you will have to balance that cut and fill, but for calculating the track hoe and the amount of time that you need the track hoe, or how many track hoes you need, you'll have to look at that for the quantities of cut and then the quantities of fill also. All right, so that's the basic concept around calculating excavation for cut and the whole cut and fill operation, and how you would determine the equipment requirements. I want to move on now and talk about the foundation design. For the foundation, this is a remote site, and so getting concrete can be very difficult because of the location of the site away from a concrete supplier. And so not just from a time factor of transportation, but just the cost of transporting that, it may require certain measures be taken in the concrete mix to slow down the setting of that concrete. So they might add some special concrete admixtures to the concrete to delay the set of the concrete, and that makes the concrete more expensive, because this has a long distance they have to travel, and they don't want this setting up too soon. So we've included that cost in this through our equipment costs. If we go back down to our equipment again here, you'll see a concrete truck which has a capacity of 9 cubic yards per truck, but it has an 8-hour round trip. So it's going to take all day for one truck to make a round trip. And so you'll have to figure out how many cubic yards of concrete you're going to need for this foundation, because that will determine how many trucks you will need. And we want to place this concrete, all at one time. We don't want to be, pour part of the foundation one day and then wait another day and pour. We like to do it all at one time so that it's one monolithic pour of concrete. So that means that you're going to need multiple trucks more than likely. So if we go back up to, well, how do we go about designing the foundation? Okay. Well, we want to make sure, first of all, that we're minimizing the amount of concrete that we need to use. And you'll notice, if you go back up to the soil chart here, that based upon the type of soil you have, the foundation depth may be different. If you're on stable rock, then you don't need to go as deep into the stable rock to get a firm soil for your foundation. But if you're using other types of soils like clay or sands, then there can be other factors that would require you to put your foundation deeper. And of course, the deeper your foundation, the more concrete that is required. So this is a variable based upon the soil type that you'll have to take into consideration. Now, if you go back, while we're here, let me also point out that different soil types have different allowable soil-bearing capacity. So some are stronger than others. Some of them may be more susceptible to settlement due to the type of soil it is, and therefore the soil bearing is limited so you don't have excessive settlement. So you can see that stable rock, as you would imagine, it can support a significantly higher load than other types of soil materials like clay and sand. And so this can have a factor in sizing your foundation as well. So how do we go about sizing the foundation? So let's go on down to that section again. And you'll see that we want to make sure that the pumps are placed on the foundation such that it will not be compromised by failure of the soil or the concrete. Okay, so the loads are designated as P. That's the weight of the pump and the structural steel skid and all of the related connections. So it's what the foundation is supporting. It's a weight that the foundation has to support. And of course, if you don't have a properly designed foundation, that can have a significant impact on the long-term stability of the equipment. You know, a pump, is a rotating piece of equipment, and it creates dynamic loading, rotational loads on our foundation, and that creates vibration. And the more vibration that you have, the more your bearings and other components can wear out. And so we have to size the foundation that's going to provide enough mass to dampen that vibration and also be able to support the weight on the type of soil conditions that we have. And so that's how we go about deciding, how big a foundation we need. Obviously, it needs to be big enough to provide full support of the entire skid. So part of that is based upon the size of your pump. And as you remember yesterday when we were talking about pump selection, these pumps are all different sizes in terms of their skid dimensions. And so the larger your pump, obviously the larger your foundation is going to be, and that's going to add to your cost because of the cost of the concrete. So obviously the smaller we can make the foundation, the more cost effective it's going to be. But the trade-off there may be your pump capacity. So you've got to look at all of these trade-offs and decide what is going to be my best cost-effective solution, considering the pump size of the pump and the cost of the concrete, and all that comes into play. Okay, so let's talk about what are the ways that we size the foundation. Okay, so first of all, this is what the foundation will look like. It may have a pedestal and a separate footing, and the footing is going to be bearing on the soil, and it'll have a certain soil pressure that's resisted by the soil. And so there's different components of the foundation: the pedestal, the footing, and the soil on top of the footing. And this loading on top of the foundation is, of course, your pump weight, and then all of this is supported by the soil. So for sizing the pedestal, it should have a plan dimension based upon the equipment base plate dimension, or the skid dimensions, plus 1 foot in each direction, rounded up to a 2-inch increment to accommodate the use of standard concrete forms. Okay, so those plan dimensions of your pump base are provided in the table for the pumps, and then you'll need to add 1 foot in both directions in a 2-inch increment, rounded up, and that would be how you size the pedestal. The pedestal should extend 1 foot vertically above grade. So your pump is going to be supported 1 foot above grade, right here. We want to get it above, if this area flooded out here, we don't want the pump to be submerged. So we like to have a little elevation, have it be elevated so that it won't get affected by water that might, collect on the site during a rain event. Okay, so then below grade, as we saw on this, you need to extend the foundation 2, 3, or 4 feet depending upon the type of soil that you have, okay? So that's how you size the pedestal. Now, the footing should be sized in plan dimension based upon the allowable soil bearing pressure, which was in the table up here. So this is the maximum allowable net soil bearing that each of these soils can provide. And then we calculate what we call Q net, which is our net soil bearing, with this formula that's provided right here. Okay, and this defines all of the different components of that. So you're taking the weight of the pump, you're taking the weight of the concrete, which is the weight of foundation, pedestal, and the footing, and also the weight of the soil that's on top of the footing. So all of this weight is combined and divided by the area of the footing base. And that's how we determine what our Q net is. Now you'll notice that we have to subtract out here the weight of the soil located above the base of this footing before construction. And the reason for that is the net soil bearing is the additional weight beyond what that soil is already experiencing, right? And so right now, if we look at this elevation of the soil right here, all of this existing soil is sitting on top of it, so it's already bearing the weight of that. So the net soil bearing is the weight that we're adding in addition to that. And so what we do is say, okay, we're taking all this weight, but we're going to subtract out the weight of soil that is already there to be able to determine what that net soil bearing is. And so it's all spelled out for you on how to calculate that. You don't need to have a civil engineering degree or be a structural engineer to be able to design that. Now, once you've determined that, you may realize that, hey, the footing size I required is actually smaller than the pedestal size. So do I make a footing that's smaller than the pedestal? And I would say, well, no, you don't want to have a footing that's smaller than the pedestal. So in the event that you find that the footing size comes out less than the planned dimension of the pedestals, then you would just extend the pedestal all the way down to the bottom of the foundation, and you would not require a footing in that case. Okay, so that's what it's saying here. You don't want to make the footing less than the pedestal size, but it doesn't have to be more than the pedestal size if you meet the requirements for the allowable soil bearing pressure, okay? And that often is the case with pumps because their plan dimensions are fairly large compared to their weight, so you might find in a lot of cases that you won't even need a footing. You just extend the pedestal down and that will be enough area to support that. Now, if you don't have a footing, then you're not going to have any of this soil above the footing, and then this equation would just be the pump weight plus the foundation weight, and then you'd subtract out this weight of soil and divide it by the area of the footing. Okay? So all that's spelled out for you there. Now you may say, okay, what is the thickness of the footing? How thick should I make this footing if I need a footing? And so we give some guidance on that here also. It says if use a thickness of 1'6". We also say that if your calculated plan dimensions of the pedestal are, if your plan dimensions of the footing are greater than plan dimensions of the pedestal, but they're less than 1 foot larger than the pedestal, then it doesn't make sense to make a footing. You know, it's more economical just to make a larger pedestal, and that's what this paragraph is saying. Okay, but let's say that you have a footing that is greater than in size than 1 foot larger than the pedestal. In that case, then you would extend that for the required dimension based upon the allowable soil bearing and make it 1'6" thick. Okay, so the thickness would be 1'6", and the plan dimension would be based upon what's required to meet the allowable soil bearing. Okay? So that's basically how you size the concrete. I think if you kind of read this some more and work out the calculation, you'll see how it's actually pretty simple. Okay, so that leads us now to the fact that we've got to construct this foundation now that we've decided what size of foundation. And so we have to provide an excavation of the soil to be able to construct the foundation. And similar to the excavation we're doing for the cut to establish a level site, we have to provide an excavation with side slopes that will maintain stability while we're constructing the foundation. Because what you don't want to have happen is people working down this hole and then have the hole collapse and people get trapped and get injured or get killed. And this actually happens quite frequently with people working in excavations that don't have safe side slopes on them. Sometimes they'll just do a vertical cut and put somebody down in a hole, and the side slopes aren't stable and it'll collapse and they'll suffocate. And so that's a really big problem, and so that's why it's important that you provide, you know, a safe excavation for them to work in and build this foundation. And so the idea then is that after you've got this level site, we're going to come back in and do some excavation for the foundation. And this will be after all our cut and fill work is completed on the site to create the level site. And so we got to create an excavation that is going to allow enough room to construct this foundation. So they're going to have to put some forms up here. They got men working down here. And so they need at least an excavation that's 2 foot larger in each direction than the base of the foundation. So that's why we say here the excavation for foundation shall have a base dimension equal to the footing plan dimensions plus 2 foot in each direction. And then from that point, that establishes this base dimension of the excavation, and then your side slope would be determined by your soil type. That was up here in our table for the soil types. The same information we used before for this cut and fill operation. All right. Now, in pricing out the equipment and the cost of this concrete and this excavation for the foundation, you're going to calculate a total cubic yards of concrete for this foundation, and that will determine how many concrete trucks you need, right? And then for the excavation and backfill, you're going to require a track hoe for that, and you'll calculate the cubic yards of excavation and then again apply that same cubic yards to backfilling this material once you have constructed the foundation, because we want to put the soil back in place around the foundation once the the concrete foundation has been completed. So that's two operations, one for excavation, one for backfill, and both of those will use a track hoe, and the quantity will be based upon the excavation quantity. Now there is one more requirement that needs to be met in addition to the requirements that I already stated above in terms of sizing your foundation. And that is that the foundation should also be sized to provide a minimum 1:3 mass ratio. And this ensures that you have enough mass to help dampen the vibrations that may occur in that pump during operation. And so once you have sized a foundation based upon the parameters we've provided up here, then you'll need to check the mass ratio. If you find out that you don't have enough mass of concrete to meet this ratio, then you're going to have to oversize your foundation to accommodate the mass ratio, even if it's not required for the soil bearing or for the minimum size pedestal required to support the pedestal. So here again, there's another criteria of consideration that may actually control the size of your foundation that you'll have to satisfy. Okay, so all of these calculations that you'll be doing for cut and fill and your excavation, for your foundation, for sizing your concrete foundation, and determining how many track hoes and concrete trucks and all that's required, you need to provide all the backup calculations for that, and they need to be shown and submitted with the native Excel file, MathCAD, or handwritten calculations that you perform for this. Now, of course, you're going to also use the estimating spreadsheet that was provided to capture the cost, the materials, equipment, and labor, but in terms of determining the quantities for excavation and backfill and concrete, you need to provide those calculations separately, and you need to show all of your work so we can see that you properly designed it and it makes sense, and that you followed all of the parameters provided in the design challenge to come up with those quantities. Okay, so that gets us through this section of how to do the excavation, the cut and fill operation, the foundation design, and how we price out the equipment. And at this point, I want to see if there might be any questions, or if David, if you want to add any additional information about this aspect of the design challenge, I think we could talk about that now.
Yeah, one quick note is for your loads P, as well as the dimensions for the pump station assembly, that you'll have to go to, I believe it's maybe table 7 towards the end, to be able to get no, not quite. Further up in the document, there will be a list. Oh, yep, right there, table 9, and it's the different pumps that have the weights identified as well as the dimensions. So that will be your input for the sizing of the foundations and the design of them.
Yeah. So see right here, it has your P. That's the same P that we showed on that foundation diagram, and remember now, we're going to have the stick build portion of this challenge that will utilize different weights and different dimensions of the pump. And so when you do your modularized version of this, then you'll have to go back and recalculate your foundation size based upon the modular size and weight for the pump. So don't forget to do that. Also, remember that with the zero-based execution, that you can consider multiple pump stations. Isn't that right, David?
Yeah, that's correct.
And so in that case, now you're going to have to look at cut and fill and foundations and excavation and backfill for the foundation for multiple sites perhaps for that, and considering different sizes of pumps and dimensions and weights and all of that. So you can see that when we look to do a zero-based execution where we're trying to be more cost-effective, it can get a little more involved in terms of the calculations that you have to do. So you have to expend some effort to save money, basically. It requires a little bit more, time and planning and figuring out how to best save money on a project. So that's the idea around that. So you'll have to look at a lot of different variables and maybe look at a lot of different options to really determine what your most cost-effective solution is. As David said, there can be multiple solutions to this, and there's not necessarily one perfect solution. There's so many variables that it would be hard to say that there's only one perfect solution to this, but it will be interesting to see how you might come up with your solution considering all of the possibilities. So that's all I have to present. So if there's some questions, then I'd be glad to answer them at this point. And of course, after today, if you all have any other questions, they can be submitted to us by email. Send them to David Bogle. He's going to be handling all the questions. Now, he may get me involved to help answer those questions, but he's going to be the one point of contact for asking any questions.
Thank you, Ron. Again, this is Aish here. At this point, we'll open up the forum for questions. I understand that it can be quite overwhelming. Yesterday, you had the hydraulic session. By the way, that will be uploaded today for you all to have access, and this will be uploaded tomorrow for all of you to have access. So, any questions so far?
Yep.
Professor Siddharthi, I accidentally muted you. Go ahead, please.
Yeah, I'm asking them, of the students, if they have questions. But nobody has a question now.
Have you gone over I have a question.
Yes.
Have you gone over the methods of selecting the pump?
I'm sorry, I couldn't hear you. Would you be able to repeat the question for me, Professor Siddharthi?
He's asking about
The method of selecting the pump.
the method of selecting the pumps.
Size and
Pump size, and I don't know what you are asking.
what are the requirements?
Okay, so that was, I think that was talked about yesterday. Is that right, David? In session 2?
Yeah, the info session 2 covered the hydraulics, and you'll have to go through the selection of the pump section, which I believe is 17 of the design challenge, or 16, and just generally what you'll have to do is run a hydraulic analysis, determine the horsepower requirements and the net positive suction head available. to locate where that pump needs to be along the pipeline route. You'll have the capability of placing at multiple locations, but your team will have to decide on the most cost-effective location. But it's the two primary criteria for horsepower and NPSHA that you'll select that pump.
So, David, one thing I would say about that is you may find that there's a optimal solution for the pump based upon hydraulics. That may not result in the best location from a standpoint of excavation or concrete. So that's why you got to look at both sides of this, and decide what's going to be your overall best cost-effective solution. So you may have a preliminary pump size and location that you've determined initially, and then when you start looking at the foundation, you might come up with a solution, but you might want to then some other cases to see, hey, can I spend a little bit more on a pump and reduce my costs by having a better location for my pump? So there's trade-offs, and you're going to have to consider various options. Don't just go with the first size of pump that seems to work best. That there may be other factors that really control the cost of the project. And that's what makes it a challenge.
Okay, we have another question. Would you please go ahead?
So when it comes to the actual physical pump layout, do we have to follow a horizontal pump layout, or can we use a vertical pump layout in order to see the space?
Well, I would say you need to follow the dimensions that are provided. Challenge, okay? So I would assume that's a horizontal layout of the pump. Is that right, David?
Yeah, and remember that we're trying to focus this particular challenge in and around the location of the pump station. So there's a lot more detail that would go into, well, one, identifying what the pump requirements are, the components in and around the pump station and the overall layout. But truly the focus is selecting the site based on our construction-driven execution philosophy. So sometimes the more knowledge you have around this particular exercise, it can be a hindrance. So we're trying to keep some of these aspects fairly simple.
Now that doesn't preclude you from, in your presentation, talking about other innovative ways or other options that may be considered reduce cost, and so certainly you can talk about those things as part of your presentation. Is that right, David?
Yes, absolutely. And part of the narrative that you'll be providing back to us will include those innovation ideas that could help improve cost, schedule, and overall design.
Okay. Any more questions, please? Any more questions?
Okay.
Okay, I think they don't have any more questions.
Okay.
Yeah, you have another question? Yes.
I have a question. Oh, you do? Okay.
Yes. Yes.
So when it comes to foundation styles, do you want us to strictly use the one that that example, or can we introduce other foundation styles? For example, instead of just using one flat slab, introduce maybe cylinders throughout the thing, so it could be more modularized. You know what I'm saying? Do they have to strictly follow that guideline, or are we open to other pieces of foundation?
Yeah. So I heard. So for the challenge, for this challenge, we want you to follow the particular foundation type that we've presented here. Now, here again, if you want to offer in your narrative, as maybe a cost alternative, innovative cost savings idea, you can also submit that as a requirement. And if you want to do some calculations or on your own to demonstrate that, that's add value to your presentation and your narrative to provide that kind of information. But for the competition here and the challenge that we're doing, we want it all to be based upon the parameters given in the design challenge.
Okay, Aish, there is no more questions.
Okay, I have a question for the students. I wanted to know just a general feedback on where are they right now with the design challenge? Have they started working on hydraulics? Any questions so far in understanding what's expected? So just a broad question, and I just wanted to solicit feedback from the students here.
One at a time. Yes, please. Yes, go ahead.
So we've
Professor Sinucci, we're not able to hear the students as they speak off of from where they are sat. So if you can please ask them to come to the mic.
Yes, go ahead, please.
It sounds like a lot of people.
Oh, okay. So they're still having, they don't have teams. They form the teams yet. So it's
Okay.
really early. Yes.
Okay, so let's see how we can help out with that. All of those who do not have teams, could you please go ahead and stand where I can see you all? How many of you are there? At least can I get a count?
Yes.
I see 3, 4. Is that it? I see 4 students over here.
No, more.
They're more than that? Okay,
Yeah.
could you give me a count, Professor Sinucci?
How many, please, can you count? 11.
11
students, yes.
So I can see 3 teams already. 3 teams of 3 members. Would you be able to perhaps talk to each other, post the session, and find your teammates and register? And 2 of you who are left out, please don't feel left out. We'll figure something out for you.
Go find something.
Yes, please go ahead.
another question. When it comes to like your whole layout design, do you want us to keep into consideration like instrumentation as well for the pipes and also the pump?
I'm afraid we couldn't hear what you just said.
Can you raise your voice?
Yeah. So.
Yes.
Essentially, when it comes to our cost analysis, we're thinking about the pipes and the pumps, and we're thinking about introducing, as well as instrumentation. Do you want us to include that in the narrative, or do we include that into the cost as well?
Okay, the question that I heard was that the current cost is only for pump and pipe, and you were asking around whether or not other instrumentation and controls could be added into it. I would not include that as part of your submittal, but yes, you can include it as part of the narrative and be able to describe the advantages around it.
Okay, so Aish, we don't have anybody, no more questions. So.
Okay, Professor Sinucci, I think there are 11 students right now. If perhaps after this session, if you're able to facilitate them forming teams, and if you're able to provide me with those who are not able to form teams, because we had a couple of students write us an email about finding a teammate, so perhaps we could help out offline with the team formation. So if you can spend some time after the session so that they can form the team and register. in order to be able to access the narrative. So that is one issue that I see that was brought up. Any other issues that you have with respect to understanding what's going on, with respect to installing AFP software on your laptop? Were you at least able to do that?
Can you please answer her question? How many people were able to run the software?
Okay.
Okay.
All right. So we just have about 4 weeks left. How many weeks left? 4 to 5 weeks left. So I think it's time
these
that...
are teams, okay? So we are talking about 5 teams, 6 teams, yes.
No, 5 weeks left. So I think it's time that, the teams are formed and people are able to, start working on the challenge itself. The other question that I had was, have the WebEx sessions been informative, or would you prefer that we come in person to arrange these WebEx for you? Not WebEx. In addition to WebEx, would you like us to be there in person to answer, to have these sessions, or do you think WebEx is sufficient? Any feedback on that? Perhaps you can send us an email, or Professor Sanucci, if you can give us a feedback later on after you talk to the students after the session, that would be helpful too. Because, we just have a couple of more sessions left, and we want to make sure that the students are not, are comfortable with this challenge and starting and are able to start work on that. So with that, any last comments, Ron, David?
I just pulled up the schedule of events just to make sure everything was clear. The due date for your proposal will be October 18th. So this portal will open on the 14th, but everything will be closed out on the 18th. So be sure to get your proposal in by then.
Ron?
I just wanted to encourage anybody. I know that a lot of you haven't really gotten into this yet, and so you may not even have generated any questions, but I'm sure as you get into it, you'll have more questions, and I want to encourage you to ask questions and don't make assumptions, because you may find if you make an assumption about something that's not correct, that will work against you when we evaluate your solution. So it's always best to ask questions, clarify your interpretation of the requirements. We do this here at Fluor a lot, because sometimes our clients give us some information and we may think we understand what the requirements are, but then find out later that that's not what they meant at all, So it's always good to have alignment with your client, and so, feel free at any time to check out your understanding with David, and we'll try to help you with that, because we want to make sure you're understanding this and applying the requirements appropriately to the design. And I'll say this right now, there's some things that we didn't give you in terms of information that you're going to have to figure out on your own. We anticipate you'll have questions, and an example of that is the fact that I didn't give you what the density of concrete is. So you're going to have to figure out, what does concrete weigh? I didn't tell you that in the challenge. So that's just one little example of not all of the information you'll need is provided in the challenge, and you'll have to maybe look for some other information or ask questions. And I always encourage students to ask more questions. That's the best way to learn.
Great point, Ron. Thank you very much, and thank you, David. Thank you, Professor Sanucci, and more importantly, thank you, students, for making the time to attend this information session. As the information session from yesterday on hydraulics will be uploaded later today, And this session on civil design and excavation will be uploaded tomorrow in the evening for all of you to have access. And they will be made available on the conference website. So with that, I will adjourn the meeting. Have a great, great day. Thank you very much.